Hello, my name is Tommy. Today we're talking about identifying chemical reactions. Work out the oxidation number for every element below. So, every element has its oxidation number, and every compound will have a different oxidation number for each element. So, any element in its elemental form, so especially like diatomic elements, will have an oxidation number of 0. So oxygen, or O2, is just 0. That's its oxidation number. Now when oxygen is bonded to anything, its oxidation number is -2. Hydrogen, when bonded to a nonmetal, has a +1. When bonded to a metal, it's -1. So since we're bonded to oxygen, or a nonmetal, we have a +2 and it equals 0, which makes sense because the charge of water is 0, and that's what oxidation number needs to add up to. So sulfate has 4 oxygens, so -2 for every oxygen, and that becomes -8. So sulfur in this case has to be +6 so it can add up to -2. So NH3, or ammonia, so we're bonded to a nonmetal, so we're going to have a +3 for hydrogen. Nitrogen is going to have to be -3 so that we can have our charge of 0. NaH, hydrogen is bonded to a metal, so it's going to be -1 this time, and sodium is going to have to be +1 to add up to the charge of 0. AgCl, the normal charge of chloride is -1, so since we're dealing with it like this, we're going to have to put it as 1 or -1. Then Ag has to be +1 to add to the charge of 0. Zinc sulfate, we know the overall charge for sulfate is -2. So we already know that our thing is -8, this thing is 6, but this whole thing is -2. So that makes our zinc have to be +2 to add up to the 0 there. For hydroxide, we have our -2 from our oxygen and our +1 from our hydrogen because we're bonded to a nonmetal. And that adds up to our negative charge. For this reaction, or for this question, identify the type of each reaction as acid-base, precipitation, or redox. So when you're looking for an acid-base reaction, what you're looking for is a transition of a proton from one element to another. So you're looking for a change in protons in your reactants to products. So with this reaction, we have HCN plus OH gives us CN minus plus H2O. So our H plus is going to our OH minus to make hydrogen, and for here, H, so this is our conjugate acid, or this is our acid, and this is our conjugate base, this is our base, and our conjugate acid. So you can see how there's a difference in protons for each of these conjugates. For a precipitation reaction, what you're looking for is aqueous solutions resulting in a product of an insoluble precipitate, or you're going to see like a little solid. So Ag aqueous plus Cl minus aqueous giving us AgCl solid, that would be an example of a precipitation reaction. Now for redox, we're looking for a transfer of electrons. And the best way you can find it is through finding an elemental compound in there, or just an element on its own. So here, with H2 and O2, we have our redox happening. So, first of all, the way you can remember reduction and oxidation from each other is oil rig. oxidation is losing electrons, and reduction is gaining electrons. So in this case, our H2, which is 0, and our O2, which is 0, goes from, so our H2 goes to +1, and our oxygen goes to -2. So our hydrogen goes from 0 to +1. So it's oxidizing because it's lost an electron. And our O, or our oxygen, is going from 0 to -2. So it's gaining an electron, or gaining 2 electrons. So that means it's reducing. And that's how you find a redox reaction.